Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about a Leetcode problem number 680, valid palindrome 2. Given a string s, return true if the s can be palindrome after deleting at most one character from it. We want to return either string is true or false by checking whether it is a palindrome after deleting one or zero elements from it. So take for example, first one is ABC, sorry, ABA. So S is equal to ABA. Whether it is a palindrome or not, it's a palindrome. It's a palindrome. Now let us see for the second example. ABCA, whether it is a palindrome or not. ABCA is a palindrome or not. It is not a palindrome. It is not a palindrome. But still, if we delete this C, then it will be the palindrome. Then this will be the palindrome, right? Palindrome is just if we read from left to right and right to left, these both will be same, right? This is the palindrome, and it is equal. It is equal. ABA and ABA, right? So this is a palindrome. Now last is the example is ABC. It is basically not a palindrome, but still, can we make a palindrome? If I delete this A, what is my string? It will be BC, right? If I delete this B, what is my string? It will be AC. If I delete the C, what is my string? It will be AB, right? Whether these are palindrome, this is not a palindrome, this is not a palindrome, this is also not a palindrome. So the answer will be false, right? We can delete at most one element, which means we can delete 0 or 1, right? So this is the explanation for this examples. Now how to approach this problem? First of all, see here what I have done here. I just took every elements and deleted them and formed a new string and checked whether the new string is palindrome or not. Just for example, A B A C A A. Now what are the possibilities I can split this? First of all, the first possibility is I can make this as B A C A A by deleting this A, right? Now by deleting this B, I can make the string as A C A. Now by deleting this A, I can make the string as A B C A. Now deleting this C, I can make the string as A B A. Now deleting this A, I can make the string as A B A C A. Now again I can delete this A and make the string as A B A C A. Right? Now I'm going to check whether this is a palindrome. Not. Whether this is a palindrome. Yes. Then whether I want to go for these all iteration or these all iteration. No, right? If they ask after deleting one elements, how many possible elements or how many possible strings can provide us palindrome, we want to go and count all these elements, right? But they are asking whether yes or no, true or false. So I can return true here, because I got a palindrome after deleting one element. That element is B. After deleting this B, I can get palindrome. So for this code, the time complexity will be what? O of n for iterating through all the elements. First we are iterating for A, then iterating for B, then iterating for C, A and C and A and A. So this is my first observation. Then for this A, how many times I am going to iterate with other elements? For n times for this all elements, right? So that will be n. Now for this sub elements, every elements, I want to again do a palindromic check, a palindrome check for this and this and for this. So this takes another n approximately. So the triangle velocity will be O of n cube. What is space? Space is O of 1, right? So this is the brute force. It's the brute force approach. Brute force approach. How can we optimize it? Whether we can optimize it. Okay. The question clearly stated that we want to delete one element. We want to delete one element. First of all, I write a string. Now, how I want to check for palindrome or not, right? How I will check? First, I take this A and this A. I want to check whether these two are equal. Yes, they are equal. Okay, fine. Now, I want to check for this B and C, whether these two are equal. Whether these two are equal. No, right? This B and C are not equal. Then I can delete this B. I can delete this B. This is my one option. Otherwise, I can delete this C. This is my another option. Fine. Let me go with this B. Let me go this with B. Right? Now, 2 pointers will be placing it, will be at the C element, right? Now, I form the palindrome. Now I form the palindrome. Right? Now, same approach number 2 for another string. Maybe we can try another string. See here, A, C, C, B, A. For example, this A and this A are same, right? Now, this C and this B, is they same? No. What we have did here, I strike out the first element. So I strike out this C. I move to next element. Whether the C and B are equal? No, right? So already I have strike out one time. Can I strike out second time? No. The question said at most 1. We can delete 1 or 0 elements, right? So I cannot delete this element. So I return false. But the answer is true, right? Because I can delete this B and make this as palindrome. So see here, I can delete this B and make this as palindrome. So we can clearly observe that we cannot delete this first element and last element specifically. We cannot delete this first and last element specifically. Then how to approach this problem? Okay, fine. I can go in both the way. I can delete first the first element, then the last element. If any one of them return true, I can return the value as true. Just see here. Same example. This and this are equal. Okay. Now this and this are not equal, right? For example, just remove this. For example, I take another example, the second example. This will be more clear, right? So this and this are equal. Now C and B are not equal. What are the two possible ways? First way is I can delete this C. And second way is I can delete this B. Right? Here will be the CB and another string will be CC. Right? So now if either of these two strings return true, I can return true, right? Because here I have deleted one element and I have searched for these two possible ways. See here, it returns no and it returns true. Then the string is true, right? The string returns true, right? So this is the approach. How to approach this problem? Let's see here. I can show you the code. First of all, n is equal to len of s. So we have stored the length of the string in the n variable. Now l comma r is equal to 0 comma n minus 1. While l is less than r, if the first element and the last element, that is the lth index element and rth index element are not equal, then I have to check whether L plus 1 comma R, that is see here, if take for example A B B C A, if this and this are cancelled, if this B and this C are not equal, I want to check for this string, so here L, here R, then I have to search for L plus 1 comma R, whether they are, it is palindrome, else I can check L comma R minus 1 is palindrome, right? So I'm going to check whether L plus 1 comma R is palindrome or L comma R minus 1 is palindrome. Now that's the code states. If that's written true, I return true. If that written false, I return false, right? Again here I do L plus 1 and R minus 1. Now see here, this check function, it just checks whether from start to end it is palindrome or not. By using while loop, I just iterated under the condition start is less than end. If s of start is not equal to s of end, if the first value and the last value are not equal, then I will return false. Else if all this all the part of the loop is executed successfully, then return true, right? So this is one approach, and we can do this thing in recursion too, right? First we can submit this. Yes, submitted successfully. And this recursion solution is not necessary for beginners. You can study recursion once and you can try to code this problem in terms of recursion, because this problem can be also solved using recursion, but still you want to use this approach because the time complexity for recursion and for this problem will be same, but still the space complexity will be optimal for this approach, not for recursion approach, because recursion stacks takes space, right? I just show that code. Just realize we can also do by use of recursion, right? See here, def rec start comma end comma flag. I'm using flag variable to denote whether it is a first time of deletion or it is a second time of deletion, right? Initially the flag will be what? True. Initially the flag will be true, and end will be the last index and start will be the first index. If start is greater than or equal to end, I want to return true because I have successfully finished every elements, right? Now if s of start is not equal to s of end, then what I have to do, I want to check whether this is first time or second time. It is first time or second time. If it is first time, the flag will be true, right? The flag will be true. If the flag is true, then I want to check for L plus 1 to R is the first check. Then second check is L to R minus 1. This is the second step, right? If the flag is true, I'll return the either of the recursion call. If the either of the recursion call is true, I will return true, right? Else the flag is not true, it is false, then it is a second time, then I will return false, right? So this is the recursion code. Again, if the statements are not get executed, I directly return like string this start plus 1 and string this end minus 1, right? So this is the recursion code. Let me run this. So fine, it is running successfully. So this is the approach for this problem. So try to code in this recursion solution too, but still you have to strong in recursion base, okay? Recursion fundamentals should be strong. Then only you understand what is used inside this recursion. Don't blindly buy out this, okay? Fine. So this is the approach for this problem. Thank you.